So let us continue from where we stopped. We're still in quartiles. Remember, this is the question we are answering. We have done parts A, B, and C before we were timed out. So now we are back to finish up D and E. So remember, first of all, we arrange them in order, and we have found our first quartile as 10. We found our second quartile to be 18. We find our third quartile to be 31. Now, the part D of the question, part D said to find the interquartile range. Okay, so interquartile range, the formula is interquartile range is written as IQR. IQR. The formula is Q3 minus Q1 as the first quartile minus the third quartile minus the first quartile. That will give you the interquartile range. Okay. So our third quartile here is 31. So I put 31. Our first quartile is 10. 10. So our interquartile range will be 31 minus 10, which we can get from our calculator as 31 minus 10. Okay. 31. You get 31 is right here.
21.
Minus 10, yeah, it's 21. Which is 21. So that will be our interquartile range. So to get the interquartile range, you get the first quartile, get the second quartile, the third quartile, and subtract, and give you 21. Yeah. Now part D says part E says find the mid quartile. The mid quartile as part E. Mid quartile is just like a rough estimate of the second quartile. So this is the formula I have for it here. I can show you from here where I listed the formulas. The mid quartile is Q1 plus Q3 divided by 2. Okay, it's just a rough estimate of the second quartile. Yeah. That's the best way to put it. So mid quartile is Q1 plus Q3 divided by 2, which means that it is Q1, which is our first quartile is 10, plus this third quartile is 31, and divide our answer by 2. I'll give us the mid quartile. 10 plus 31 divided by 2. So we got 10 plus 31. Okay. 10 plus 31 divided by 2. It was 20.5. That is our mid quartile. 20.5. Okay. You can see that it gives us a rough, not exactly estimate of. See, our second quartile is 18. This is 20.5. Just a little bit off, just a rough estimate of the second quartile. And that's it for that question. Now we can look at another example. Then we can look at the applications. The example is this one here. It says, find Q1, Q2, and Q3 for the data set. This one, they didn't tell us where the data set was collected, but they just asked us to find the Q1, Q2, and Q3. So first of all, we arrange them in order. Let me put solution here. Solution. Arrange them in order from the smallest to largest. And we begin work. We go to work. The first one is first quartile. If you remember, the formula is this. For the quartile is this. N times P over N. I'm going to move it down so we can have more room. Okay. We have it as N times P over N. Okay. Okay. All right, we have give me 1 minute. Give me 1 minute. Okay. So we have it here. First one, Q1 equals N here, or N. Our N here is how many of them? 1, 2, 3, 4, 5, 6, 7, 8 of them. 2, 4, it's 8. So I'm gonna change this to regular N. Then, so now our P, because this is say find the Q1. Oh, okay, this is, you know, I'm doing it at the wrong section. See, look, I'm gonna copy this from here. Okay, this is what I'm doing right here. Same thing. So I put it in order. In order, see. So our Q1 will be, so in this case, our P equals first quartile, which is 25. So we can now begin. N times P over 100 becomes 8 times 25. Okay, over 100. It means
where's 25 coming from? Excuse me.
Huh?
Where's 25 coming from?
Yeah, that means you joined late. Okay, let me show you. In quartile, first quartile is first 25%. Second quartile is 50, halfway. Third quartile is 25. Did that answer your question?
Yes, thank you. I get it.
Welcome. So we have it here. Where is it? So we have 8 times 25. We got 8 times 25. So we got 8 times. Okay, over 100. Now this time we got a whole number, which is 2. Unlike before, we used to, remember, if you get a decimal number with a decimal part, go to next number, right? But if you get a number that this one that has no decimal part, that means you're gonna use this number plus the next number. So in this case, it gives us 2, which is not, there's no decimal. So which means 2, so that Q1 becomes the second number plus the third number divided by 2. So the second number here is 1, 2, this is 6 is the second number. 6 plus the third number is 12. Because this is the second and third divided by 2. So second plus third, 6 plus 12 is 18. Divided by 2 is 9. Yeah.
Okay, so when we get a whole number, we take that number and the next number and do this.
Divided by 2. Yes. Yes.
Okay.
So Q2 becomes, for Q2, N is
Excuse me, Professor.
yes.
Yeah, for quartile 1, I think it should be 8 times 25 divided by 100. That gives us the position. That's the second position. And the actual quartile should be 6. So how come about 6 plus 12? And I don't understand.
It shouldn't be 6. If you get it, I repeat again, if you get a decimal number, you go to the next number. If I got 2.1, then you can say, go to the third number, which is 6. But if you get a whole number like this, use that number plus the next number. So that means the second plus the third. By 2.
Okay, I got you. Thank you.
You're welcome. So please, 50.
I have a question. So if it's, say the number was 2.1, that means it could have been 3, right? So
yes.
So the answer could have been 12?
Yes.
Okay.
So next one will be Q2. So Q2 will be 8 times 50 divided by 100. So we look at 8 times 50. 8 times 50, which we can get from here. Change this to 50. Again, we get a whole number, which is 4. 4 is a whole number. So we get that our second quartile, so that second quartile Q2 equals the fourth number plus the fifth number divided by 2, which means the fourth number. So 1, 2, 3, 4 is 13 plus the fifth number. So 1, 2, 3, 4. The fifth number is 15. Okay, divided by 2. So 13 plus 15 divided by 2. 13 plus 15.
It's 14.
Huh?
14, because it's 28.
Is it 14?
Yeah, because it's 28.
14, then it's 14 then. Okay. Now the third number, third quartile, which is Q3. So in that case, we do the same process. Have it, but this time P is 75. So that we have it Q3 becomes have 8 times 75 divided by 100, which is 8 times 75 divided by 100. From our calculator, change this to 75. Okay, divided by 100, 6. That be 6. Okay. Oh, excuse me. I gotta take you to the back to the workbook. What is it? What is it? What is it? What is it? Okay, this is the screen. This is it right here. 6th number. Now, can you see the screen? Okay, I'm gonna do it this way. Can you see my screen? Our workbook. Can you see it?
Yes.
Yes.
Okay, good.
Yes.
That's 6, right? So that Q3 equals the 6th number plus the 7th number divided by 2, which is the 6th number will be 1, 2, 3, 4, 5, 6, 8, 7, and the 7th number is 22. So 8 plus 22, the 18 plus 22. 18 plus 22 divided by 2. That will give us 20, I believe. 20. You can double check it. So so I've shown you how to do it when you get a decimal part. Like here, if you get a decimal, you run to the next number and count. And I'll also show you how to get it when there's no decimal part. So in the remaining 2 examples, I'm not going to start solving this. I'm just going to give you my results, share it to use it to explain. Okay. All right. Let's look at this. Here it says, check the following data set for outliers. Now, I'm going to explain to you how to do that. Now, to check for outliers, this is what you need to do. First thing is to find Q1 and Q3, not Q2, Q3, not Q3. So, like I said, I've shown you the both ways of doing it, so I'm not going to solve them again. I'll just give you my results. Find Q1 and Q3, then find the IQR. I explained that IQR is simply Q3 minus Q1. Then you check the data set that fall out of this range. So we're going to do it right now. Okay. Here we have, it says here to check these data sets. Check the following data set for outliers. So first thing you do is to arrange them in order from smallest to largest, then find Q1 and Q3. Now I have shown you how to find them, so I'm not gonna do those once again. I'm just gonna write my answers. So solution here, I got the answer I got for Q1 for this question is I got Q1. Just give me 1 minute. Got my Q1 as 9. Okay. And I got my Q3 following the method I explained previously. I got my Q3 as 20. Okay. And then next thing I do is to find the IQR, interquartile range. IQR equals Q3 minus Q1, which means 20 minus 9, and that'll give me 11. IQR is 11. Next thing I'll do now, I'll find the lower interval and upper interval, and any number that falls outside those interval will be the outlier. So let me get the lower interval. Lower interval will be Q1 minus 1.5. 1.5 is just a part of the formula. 1.5 times IQR times IQR. That means Q1, our Q1 is 9 minus 1.5 times IQR. Our IQR is, we get it here as 11. All right. So I'm going to put this on the calculator. Here, what is my calculator? What is it? Yeah.
I have a question. Where did the 1.5 come from?
It's part of the formula.
Okay. Is it written somewhere?
No, it's just part of the formula.
So when we're doing this formula, it would always be 1.5.
Yeah, I think let me show you something.
Okay.
If you scroll up, you can see where I wrote it down. See, it's part of the formula 1.5.
Okay. All right. And all of this is going to be posted in the files.
I think I have it already. If one this I'm gonna post this version tonight. The one we did last time, I posted it. So I'm gonna post this one after tonight. Every night I'll post it so I can always review.
And they're posted
and the video too.
They're posted on the files, or where can I find it? Because I was looking.
It'll be on the files, yes.
Okay, all right, thank you.
Okay. So we have so I got Q1, which is I got Q1 as 9 minus 1.5 times IQR of 11. Negative 7.5. Give me negative 7.5. Negative 7.5. And we repeat the same process to find the upper end. The upper end of it. We're going to use Q3. plus, this time we use plus 1.5 times IQR. And our Q3 is 20 plus 1.5 times IQR of 11. So that the upper end will be 20 plus 1.5 times 11 is 36.5. 36.5. 36.5. Now we look for a number that is, we check the upper and lower. If you see any of this number that is doesn't fall, is there any number here that fall below the lower end? There's none. The lower end is negative 7.5. There's none of these numbers fall below that. Now let's look at the upper end. Is there any of this number that is bigger than the upper end? The upper end is 36.5. And the only number bigger than that is 50. So that means our outlier is 50. Equals 50. Because it falls outside the interval. Questions? Questions?
Professor, how about the lower interval?
Lower interval is negative 7.5, and there's no number here that is below that. Is there?
No, so
there's none on the lower end. On the upper end, is there a number bigger than 36.5? Yes, there is. It's 50, and 50 becomes the outlier.
So okay, outlier is the number bigger than the answer rate.
Either lower than, either that is outside the interval, either that is lower than the lower interval, or that is upper than the upper interval. Okay. So now, since there's no more question, we can look at the exploratory data analysis. The purpose here is to analyze, to examine data to find if there is any center or spread on it. So usually we ask a question like, the question will say, find a 5-number summary of that data set. Again, I have already shown you how to calculate Q1, Q2, and Q3. So I'm not gonna repeat them here. I'll just give you my results and then answer the question. So if you're asked to do this, that question is find the Q1, Q2, Q3. And then using the method I explained to you, okay? Now look at this. It says, a stockbroker recorded the number of clients she saw each day over an 11-day period.
Excuse me, Professor, before you, I'm sorry to take you back. Can you go to the formula for the upper interval? Please. Please. Okay, for the lower interval, it should be Q1 minus 1.5, and the upper is Q1 plus 1.5.
Q1 minus 1.5 times IQR.
Okay, plus and minus.
You got it now, right?
Yeah, thank you.
Welcome. Now, say a stockbroker recorded the number of clients she saw each day over an 11-day period. The data are shown below. Say identify the 5-number summary and construct a box plot to present this data. So first solution, the first thing to do is to put them in order. Now, like I said, I'm not going to start calculating them here because I have already shown you how to do it. So I'm just going to put my answers here. But I'm going to answer the main question they want here, which is to find the 5-number summary. So the 5-number summary means I'm going to move this down so we can have more room. Okay, now we have enough room. 5-number summary. First of all, find the minimum number there, which is the minimum smallest number there is 23. Okay, maximum. Yeah, maximum. Which largest number there is 51. Then Q1, I'll give you the answers I got for Q1 and Q2. My Q1 I got 29. And my Q2, I got Q2, I got 33. And Q3, the answer I got from my Q3 using the method I explained to you, 42. So we have answered the first part, 5 numbers. Remember, in exam, you have to calculate the Q1, Q2, Q3 using the method I explained. So now we have answered this part. Now let's answer the other part. It says construct a box plot. To draw the box plot, you have to look at your data set. See, it's the smallest is 23, the largest is 51. So you can decide where to start. So you're gonna start from 20. So I'm gonna start from 20. Okay. 5, 30. I think I put this in here. 30, 35, 40, 45, 50, 55. Okay. Now, with this, you are ready to draw. I can just use your pencil. Now, some computers have some Excel have can draw can draw a box plot.
I have a question.
Once you put your data in.
I have
Yes?
a question. Where's the 20? Where's the last number, set of numbers that you write down come from?
Number. This one?
No, the 20, 25, 30, 35.
Okay.
Down there.
You're making a scale. I'm making a scale to draw. When you want to draw a graph, you make a graph, you make a scale. You remember your algebra class?
Okay, okay.
So that's how you make a scale. Now we have our arm. I'm going to draw it from here. Maybe from here. Maybe I can move them a little bit. So I have the box plot. I can put the box right here. In the test, you will have the they'll give you the tools that you use for the on the homework. They'll give you the two. They made the Q2 is 33, is 30, 35. So 33 should be around here. Draw it. Okay. So that is the 33. And this one is first one here is the 29. So I'm gonna move it to making sure it's on 29. This is 30. So 29 should be very close. Okay, okay. Okay, okay, so I'm gonna see. It won't let me move this out. Let me see why it won't let me move it. Okay, you know what? I'm gonna try to draw it with use regular drawing. So I'm gonna just use lines. So the drawing will be here. The line should be around here. So I'm gonna put it right there. Okay. It doesn't go up. Okay. The next one is that 42. Okay, 42, 45, 42 should be in this neighborhood here. Then we can now I think the best thing for me to use is to use the pause and stop where I'm supposed to. Can we put this? You know what I'm gonna do? I think I get the idea. Let me just use this. Yes. You know, in the classroom, this is easy in the classroom, but with this Word document, sometimes it can be challenging, but we'll figure it out. Yeah, let me try it again using this box. So we'll start on 29th, draw it. Oops. 29th. Okay, 29 to, we have only 10 minutes left. 29 from here. 29 starts. 42 should be around here. Then we can now insert the 33 here. 33 should be here. So this is 29. 29. 33. 42. Now I'm gonna remove this 33 here. Now we can get our whiskers. Our whiskers will be from here. Lowest number is 29. Sorry, the lowest number is 23 right here. So we should be around this place. And the highest number there is 51. 51 should be here. Then we can put the whiskers. Yeah. Okay, that's our bus plot right there. Okay, that's this number here. So you can see that in the bus plot, this part is stretched more. So we have that, you see, it is skewed to the right. Interpreting shape, describing the shape according to the bus plots. In bus plots, this data set is skewed to the right. Because it's bigger on this side, on the right side, it's stretched for the other side. I mean, it is not symmetric, it's positively skewed. Any question on this?
Can you come again with what you just said?
It is skewed to the right, because this side is bigger than the right side is bigger than the left side. Yeah.
Is it positive or negative?
It is skewed to the right. It is positively skewed. It is skewed to the left, then it's negatively skewed. But this time it is skewed to the right, so it should be positively skewed.
Okay.
So we finished method measures of position. We have only 7 minutes left. I will use that 7 minutes to introduce you to the empirical rule and Chebyshev's theorem. Under the empirical rule, he said that for any data set having a distribution that is bell-shaped, that is bell-shaped, then the following properties applies. That about 68% of all values fall within one standard deviation of the mean. About 95% fall within 2 standard deviations of the mean. About 99.7% fall within 3 standard deviations of the mean. So these are set in stones, because this refers to a distribution that is bell-shaped. Remember when we did shape of distribution, I explained what you mean by to be bell-shaped, to be right skewed, to be left skewed. And so I explained that when we did a shape of distribution. So this one is used for the distribution that is bell-shaped. For that distribution, most of the data fall within this 95%, most majority. So see, if you look at this, if you look at the chart, you can see this from here to here. Give us the 34, give us 68%. Now, if you add all this from this point with 2 standard deviation to this point with 2 standard deviation, you get 95%. And you will see that this is where most of them fall. And I give you an example. Normal blood pressure, normal sugar level, normal height of adults, and so on and so forth. For it. Now, any one that fall far away, like here, 99%, that means only from this section here. this part, and that means it's not usual. So I would say that, put it this way, what we usually have in life, what we call normal, usual values are fall under this 99%. So 95%, I mean to say 99%, usual, what we call usual, fall within this 95%. So that's where most of the data values fall, from here to here. But one that fall outside this range, like here, it become unusual. Like somebody who is if you see somebody who is a professor and he's also a millionaire, you know that is unusual. I mean, professors can be rich, but normally we are middle class. We're in the middle class. But if you see a professor that's become a millionaire, I mean, that is unusual. It can happen, but it's unusual. Another example, like we have a normal blood pressure, or normal blood sugar. Then somebody who has diabetes might have unusual blood pressure. The same thing with here, we have unusual. Anything that is here is also unusual. Yeah, so I'm gonna use this drawing to show you. I'm using this many minutes to explain all this so that you can, when we got back, we jump right into it. So from here is unusual. Yeah. So anything from that section, from here, from this spot here to this, unusual. I'm sure you guys must have heard of people that we call genius. That we say that they are genius because they have unusual talents. People can be smart. You don't have to be a genius to be smart. You study hard, work hard, you become smart. Know your book. But genius do something that is that are very extra smart. So we call them unusual. I'm sure if you are working in organizations or businesses, you can see them talking about Six Sigma. Six Sigma. It has to do with quality control. Now, this is unusual. The one we're using this only is 3 standard deviation. I mean 3 sigma. So 6 sigma that is almost like perfect. You know, perfect. The one we have, the highest we have here is 3 sigma. That's 3 times standard deviation. Now, I want you to notice one thing again. If you look at this, you can see that what you have on the right side is the same thing you have on the left side, except that in the right side we use plus, and in the left side we use minus, and in the center we have only one V. So don't forget that we use it's general for symmetric. Empirical rule. So if you are in summary, before we are timed up, data entries that lies more than 2 standard deviations of the mean are considered unusual. See, 2 standard deviations of the mean. So the negative sign is just to tell that it's on the left side. The positive that is on the right. So 2 standard. Anyone that lies beyond 2 standard deviations is unusual. While those that lie more than 3 standard deviations are very unusual. So empirical rule applied to every symmetric distribution. So in general, we use the empirical rule and this equation, mean plus or minus standard the number of standard deviations times the standard deviation. So so the standard deviation times the number this S can be any can be 1, can be 2, can be 3, so for the population. So that's why you have a mean minus 1 standard deviation, mean minus 2 standard deviation, and you have the corresponding mean plus 2 standard deviation on both sides. So I'm gonna we have less than a minute. I'm gonna close it now. So you jump back in, log back in the next 10 minutes, okay?